All right, let's get started. Thanks y'all for coming. This is the Backend, saving and retrieving data in an app, part of the Makeathon workshop series. I am the computer science professor of the practice. My office is actually like a stone's throw from here, right down the hall. Not that we'll be throwing stones, but the Backend. Today we'll be learning how to build a backend, what a backend is, and what it's for. I'll be doing an extended example where I'll be building a backend here in front of you all. And hopefully by the end of it, you'll be able to build your own backend. That'll be the sort of practice part of this. Okay, so what problem is a backend solving? It's important to think about this in the context of apps that you use. All apps use data in some capacity, otherwise it wouldn't be interesting at all. But the question kind of that brings us to a backend is, where does the data need to live? Now, some data can live on the device. Maybe you have some settings for an app that you've saved. Those can live on the device, and that's somewhat okay. One potential issue is that if you lose your device, you lose those settings. But also, if that data needs to be shared with anybody else, there needs to be a centralized location for the data. The data needs to be stored usually in the cloud somewhere, whatever in the cloud means exactly. So the point of that is that there is a single source of truth for the data. There's a server somewhere that has all of the data that all of the apps and all of the different clients are using, and that's the source of truth. So if you're sending a message to somebody, say, then that centralized server needs to know that you're sending a message and who you are and who you're sending it to and all of that information, so that the person who's going to be receiving that message can also access it. If that message only lived on your device, then it wouldn't be possible to share that information. So that central location is the source of truth, and that location is essentially called the backend. It's also called the server side, or maybe just this server. Now, there might, in some cases, be a more complicated backend that involves multiple servers on multiple machines. In the case of something like Google or Facebook, there are probably thousands, if not tens or hundreds of thousands of individual machines that together comprise the backend. But for our purposes, we're just going to be talking about a single backend server. And this is as opposed to the front end or the client. Client side is the application code that's running on the user's device. And so when you're running an app on your phone or running an app through a web page, you are the client. And any code that runs on your device, whether that's in your web browser or on your phone, is part of the front-end code. We're not going to be talking about the front-end code. We're only going to be talking about the back-end code. And this is code that is useful for both mobile apps that run on phones and tablets and things like that, and also for web apps. Web apps need a backend too. Think about Facebook as kind of a web app that you can run in your browser. That needs a backend because that data isn't just living on your device. That data is stored in some central location. Okay, so we're going to be talking about the backend. There's a couple of different pieces of the backend. The first piece is the database, and this is what is actually storing the database in a durable fashion. You might also say in a persistent fashion. That's another word that we use sometimes. And what that means is that if some machine crashes or needs to be rebooted for maintenance or something like that, that data is still going to be there. So a database is going to be using disks in some fashion, like a solid-state drive or a hard drive, or in some cases like tape drives and things like that. But there's some sort of solid memory that needs to contain the data, so that it's not just stored in the computer's RAM and you're going to lose it when it reboots. That's one component. The other component is the API server. I'll talk about what an API is in just a minute. We're going to dig into that in quite a bit more detail because it's a pretty important part about how a backend works and how to build one. But essentially, the API server sits in between all of the clients that are out there and your one database that is your source of truth. That API server sits in between those things, and it mediates access to the database. Why do it that way? Why not just have the database also be an API server? Well, the answer depends a little. I mean, you kind of have to know what an API server is doing somewhat to be able to answer that question. But in essence, the reason why people do it this way is to separate concerns. Separating concerns is a really good idea when you get to fairly complex programming, because that way you can focus on one thing at a time and not get overwhelmed. So for example, some of the concerns that an API server handles that a database does not is HTTP requests. Your API server is going to be doing that, and that's going to be basically the language that the client and your API server are speaking, but the database doesn't need to know that language. Your API server is going to be doing authentication and authorization checks. In other words, are you who you say you are? And do you have access to get the data that you're asking for or to store the data that you're trying to store? The database doesn't usually need to care about that. You also want to limit the types of interactions that clients can have with data. You don't want to let clients do whatever they want with your database. You want to provide some level of control, as I kind of alluded to just a minute ago with authentication and authorization. You don't want to give them unmitigated access. You want to restrain what clients can do. An important note is that clients are running on devices that you don't control. And so clients might be able to hack in and change the code that's running. Maybe you wrote that code, but maybe they can go in and change it so that it's doing subtly different things. Maybe they're trying to get access to something that they shouldn't have access to. So you can't trust that the code running on a client device is the same code necessarily that you wrote. You have to treat these incoming requests as untrusted requests and validate them. And then finally, if you try to do an API server as part of a database, you would need to extend the database to handle that kind of stuff. And it's basically just a lot easier, primarily for the reason of separation of concerns, to write your own backend in your own language as a separate program. So those are the two components, database and API server. The thing that we're going to be focusing most of all on is the API server portion of this. Backend programmers generally are going to use a database, but not develop one. But they are going to develop and create an API server. So most of the work of backend programming is in creating this API server. And to do that, you have to use a database, but you're not actually creating the database software itself. OK, and that's what we're going to do today as well. We're going to use a database and create an API server. So I keep talking about API, and I haven't defined that term yet, so now it's time for me to define it. API is an acronym that stands for Application Programming Interface. The word interface comes up a fair bit in programming in various respects. Something that you may have heard is user interface, and these are just the ways that a user can interact with your program. And that's all interface means. It's just a way of interacting. And an API is the same thing. Notice the word interface is there in the acronym. An application programming interface, though, does not serve users directly. It serves programs. And that's why it's called an application programming interface. It's because it's serving programs and applications that need access to the data. And specifically, the primary program that's going to need access to the data provided by an API server is the front end, which is code that you're probably going to write also if you're working on an app. You're going to write the backend API server, and you're also going to write code for the front end so that the user interface is programmed as well. And as I mentioned a minute ago, in terms of limiting the types of interactions that users can have with the database, this is what an API does. It defines certain ways that front-end code and external clients can save and retrieve data. And you are only defining specific ways of interacting. And these ways are called endpoints. So an API, really all it is it's a set of endpoints. And an endpoint is a specific way that a user can either, and I say user, not like a person, but some program that's using the API, can either access data of some sort or store data somehow. So we'll talk about endpoints in just a minute. But the point of an API is that you have to define your own API that makes sense for your app and your data. This is not something that you can just use somebody else's API unless somebody else owns the data and has provided their own API to access it. For example, you might use I don't know, GitHub's API to look up statistics about code and repositories that GitHub owns, different things like that. Or maybe you would use, I don't know, Facebook's API if you were trying to write an app that integrated with Facebook Messenger or something like that. So these APIs do exist that you can use, but for the most part, if you're writing some app of your own and you're going to own your own data, you're going to have to write your own API to specify exactly how your app can access the data. And we'll dig into this in a minute and see an example of an API to make this a little bit more concrete. Generally speaking, modern APIs use HTTP. That's not a requirement of an API, but it is far and away the most common thing that APIs do these days. HTTP, if you haven't seen that before, that's the thing that gets added usually implicitly to things that you type into the address bar of your browser, because HTTP is the Hypertext Transfer Protocol. So this originated as part of the web, and browsers, in fact, use HTTP almost exclusively. There are different types of interactions and protocols that browsers understand, but for the most part, most of what they're doing is HTTP only. HTTP or the secure variant, HTTPS, of course. And in order to implement an API, we need to understand a few things about HTTP and how it works. We're not going to dig into the gory details of it, but we need to understand some sort of high-level properties of the information that is contained in HTTP. So let's talk about that. There are two types of messages that are sent in HTTP, requests and responses, and those are probably what you would expect. What happens is you have a web server that lives somewhere out there, and you access it probably through a domain name of some sort. And when you access it, let's say you type in twitter.com in your browser address bar and hit enter, your browser is going to be the client accessing the twitter.com server. And so your browser is going to be sending an HTTP request with certain information in it, indicating what is it that is being requested. And twitter.com is going to respond with the information that's requested, or possibly an error code of some sort. But those are the two different types of messages, requests and responses. Requests have certain types of information in them. Some are kind of required and always present. Others are optional. They have a method. A method, the two most common would be get or post. Get is sort of the default action. Like if you need to get something from a server, you would say, I need to get this, and get would be your method. Post would be, I have some data for you, server. And this would be more like you are writing data to the server or trying to store it somehow on the server. By the way, whenever you submit a form, that's usually being submitted as part of a post request. There's also a URL that you're accessing. And it's kind of more a URL fragment. You do have to specify what host you're connecting to, but for the most part, it's just the stuff after the host. So if you're trying to access twitter.com/timeline, I don't even know if that's a real URL, then you would connect to twitter.com, but your actual request path would be like /timeline. So that's part of a request. Requests might also have parameters, and they might also have a body. And these are different ways that you can add information to your request to specify the kinds of things that you're wanting. For the most part, GET requests do not have a body, but POST requests and PUT requests often do, and that's more on the right side when you're trying to write data to the API server. But parameters might be something like if you pay attention and you go to like google.com and search for something there and hit enter, there are GET parameters on the GET request, and you can actually see those in your address bar. It begins with question mark, and then it might say search string equals this thing, and different parameters might be added on there. So that would be an example of parameters being added to an HTTP request. Responses have a status code, and usually they have a body. They don't have to. The status code might indicate, is this a successful response? Was I able to do what the request asked? Or is there some sort of problem? And then there are a lot of different types of error codes that might be used. You might say like bad request is 400, not found is 404, like I couldn't find what you're looking for. There's even one 500 for internal server error in case there's like some sort of a bug or something happened on the server side that wasn't anticipated. All messages have headers, and they have extra information in them. Most headers are not required, but they're just a way to add extra information to a request or a response, like cookies. Cookies are information that's actually stored client side, like in the browser. A common header is a content type. Anytime there's a body, you have to specify how to interpret that body. And a common one that we'll see with APIs is JSON. And we'll get into what that looks like in a minute. But one of the most common content types would be text HTML. And that would be for, if you're just requesting an HTML document, the content type would be text HTML. And that's just a way to say, this is how you should interpret the data that I'm sending you. OK, we talked about request methods already. And you can actually inspect HTTP messages in your browser. So I'm going to do that real quick. I actually don't know. Let's go to google.com, I guess. If I open up my developer tools, web developer, I'm using Firefox. A similar kind of thing exists in Chrome. And I can open up my network tab of my web developer and reload. And I need to stop filtering those requests. And you can see my browser submitted, I don't know, I guess 28 requests just to pull up google.com. That's the root request. And you can actually inspect all of this stuff. So this is you can see a request method is get for the request. It's requesting this URL. It found that server at this IP address, which is, I'm not going to get into. It got a response back of 200 OK. So that's a success response. You can see the actual headers, including content type is text HTML. That's what I just talked about. Separate headers for the request. Looks like I gave Google a cookie. You can look in more detail at the cookie information that was sent and received. I didn't send any parameters. So anyway, you can dig into the details of all of this kind of stuff, which is kind of fun to just be able to inspect that. But back to the slides here. OK, so that's HTTP. And as I said, that's important because most APIs use HTTP to interact with their clients. So the server is going to be receiving HTTP requests. And every time it receives an HTTP request, it needs to respond with an HTTP response. So in general, if you're trying to build an app, the development process goes something like this. I usually recommend to people as a first step to design screens that users will see. And this would be using a tool, you could even just sketch on a whiteboard, just sketch what the screen should look like and map out all of the different screens that your app is going to contain. I think this is a really excellent way to start because it makes your ideas concrete and it forces you to wrestle with, OK, what exactly is going to be in this app? How are users going to interact with it? And a lot of times that process of trying to make your vision more specific and concrete can be really helpful to guide the process of developing the app in general. So I recommend that as a first step. But once you're past that, the next step would be to define an API. Not sure what happened there. OK. Define an API. So we just talked about what an API is. I will define an API for an example app in just a minute to show you that. In fact, all of this I'm going to be doing except for the screens and except for the bottom one, profit. I'm not going to be profiting on the code that I'm writing here that I know of. But I will be covering this middle chunk. So I'm going to be defining an API. And then in parallel, what we can do is develop the backend and develop the front end. Usually the front end is going to have some code of its own. We're going to be focusing on the backend portion for this talk, obviously. And at some point, once you've kind of developed everything and got it into a more or less working state, you want to deploy it somewhere so that other people can access it. And I'll cover that piece as well. So here's an outline for the rest of the talk. First, I will talk about what we're building here. Then I will define an API, so you'll get to see that. I will write some backend code. I actually will write a little bit of front-end code to illustrate what that looks like. It's not going to be a complete app, but just enough to illustrate how to connect to the API server from front-end code. And then I'll start using a database. And then I will deploy it. I'm going to be deploying it to a service called Heroku. And then finally, once I'm all done with that, you all get to practice these things that I'm talking about to build a simple API of your own. OK, so what are we going to build? We're going to do just a pretty rudimentary social networking backend inspired by Twitter. I just picked an example that was simple enough that I could actually do it in the course of a talk like this, but something that was relatable that I hope most of you understand what I'm talking about with a simple description like that. So my API server that I'm going to build is going to have 4 supported actions. Remember, this is kind of talking about the API endpoints. These are the specific things that we're allowing our clients to do to the data that we control. We're only allowing them to do that thing. Was there a question? OK. First of all, we want to be able to create a tweet. We want to be able to see tweets for a user. We want to be able to like a tweet, presumably as a different user. And we want to be able to see likes for a tweet. So these are the things that we'll be implementing today. All right, next, let's define the API. So in general, when we're defining, we're going to define 4 endpoints corresponding to those actions. And our task when we're defining an endpoint is to define expectations for HTTP requests and HTTP responses. That definition is usually going to be documented somewhere so that it can be referred to later by both back-end programmers and front-end programmers, or if you're the only one developing by yourself when you forget some of these details. But we need to be as specific as possible about what we expect in an HTTP request and what kinds of guarantees we can provide in a response. So in this case, we're talking about creating a tweet. That's the endpoint that we're defining. And we're going to say that the request should have a method of post. It should have a path of tweet/tweet. It should have a content type of JSON. The content type goes along with the body, so we know that there is going to be a body with this request. And the body should have, it is going to be JSON, and it should have 2 properties, handle and body, both of which are strings. The response, if these expectations about what the request is are not met, then it's going to return a code of 400, which is shorthand for bad request, and a body that explains why. Maybe they didn't give us JSON content. Maybe the request had a handle but not a body, or maybe the body was an array instead of a string. All of these things are things we would need to check for and return an appropriate code for, a 400 code if that wasn't met. If the expectations are met, then we should return a code, the response should have a code of 201, which is shorthand for created, and a JSON body of the tweet, including an ID for that tweet. Even though the request didn't specify an ID, the response is going to specify an ID. And that's something that often happens most of the time in an API, is that the IDs are sort of the responsibility of the back end to control, not the front end. And that is one way to avoid conflicts. If the clients were controlling the IDs, then 2 people could ask to create the same tweet with ID 3, and you'd have different definitions about which tweet that was. I'm using the shorthand here. I'm just saying JSON body. That's shorthand for having a content type header of JSON and then the body being such and such. OK, let's look at the definition for the endpoint for seeing tweets for a user. The request should have a method of get, and it should have a URL path of /t/some handle, like a username. No other requirements for the request. A lot of times the GET requests are the easiest ones to handle. They don't have a body most of the time. The response should always have a code of 200 OK. It should have a JSON body of tweets by that user. It should include the IDs in the tweets, and it should sort the tweets most recent first. Now, if we were doing this for real, we would probably also support a response code of 404, not found. But right now, we don't have any separate notion of which users are registered. So we'll just always return 200. And in some cases, if they ask for tweets for a user that doesn't exist, they'll just get an empty set back. A third endpoint is liking a tweet. We'll say that this needs to have a method, the request needs to have a method of put, and the path should be /like. And the request should have a JSON body with 2 string properties, handle and tweet ID, both strings. This time we are going to return 404 not found if the tweet was not found, because this time we're taking a tweet ID as a parameter, and we need to try to find a very specific tweet that we're going to like. And if we can't find that, we should let the user know somehow. Otherwise, if it is found, we should have a code of 201 which is created, and the response should have a JSON body with the like details echoed back, basically just the same things that were sent in the request. Are you starting to see kind of how specific we need to be here with these endpoints? Like, the more specific we can be, the better. Finally, for seeing tweet details, similar kind of thing. Should have a method of it's actually not right. Should have a method of get. Should have a URL path of /tweet/some ID. And the response, again, will have a 404 if we couldn't find that tweet, or a 200 if you could, along with 2 properties, tweet and likes. And I should probably specify more detail about exactly what will be inside those, because those are going to be objects with more information, but I'm going to elide those details. So in summary, here's our API. And this would maybe not be exactly what we would document and give to somebody who is writing the front end. We might have a little bit more detail on it than this, but this is a nice, concise summary of what we'll be implementing in just a minute. So I'm not going to cover that again, because I just did. But great. Now let's write some backend code. So I'm going to be basically implementing each of these API endpoints. And all right. To do that, I'm going to be writing this in JavaScript. Quick straw poll: who knows JavaScript here? A couple people. Who's even a programmer here? Are y'all here? Do you have any experience programming? A little bit. Okay. Who's not a programmer? Okay. All right. So some of each. I'll try to kind of cover the middle here, and hopefully won't lose those of you who aren't programmers too badly, and won't bore those of you who are programmers too badly. If you are not a programmer, I would say, I guess I would give this sort of caveat here. I don't expect that you're going to know how to program a backend at the end of this talk. I don't think that's a reasonable thing to learn in the space of 2 hours, no matter how good of a teacher I might be. I think what I would focus on, if you're not a programmer, is just trying to understand why what I'm doing works, without trying to figure out, okay, how would I come up with that on my own? And I'll be explaining as I go, so hopefully you'll be able to follow along. All right, so to start with, I'm going to create a new JavaScript project. I have a program called Node.js installed, which is a way to access JavaScript from my computer, which is to say outside of a browser context. And here is a, oh, you know what? I forgot to specify a project name. So I'll call this Backend Demo. Let's see. Okay, I did this wrong apparently. Make dear backend demo npm init y. Okay. So now we have a new project. This thing that it wrote, package.json, is just indicating kind of the contents of this project, what the name is, description, as well as any dependencies that it might have, which it doesn't yet, but it will soon. Is there a question?
Yes. When you type npm init -1 backend demo, automatically it will be produce the JSON file, right?
I think that time it failed. I think what I ended up needing to do is to create the directory first and then change into it, cd into that directory, and then I can just say npm init-y, and that time it succeeds.
So automatically it will be produce the JSON file, right?
Package.json, yep. Okay. Yep, wrote to that file. Mm-hmm. And we can see that's exactly what it said it was. Yep, okay. So we have a basic project in place. What I'm going to do is create a source directory and a file in source called index.js. This touch command just creates a file. So now the contents of my current directory are a package.json file, a source directory, and an index.js file that's currently empty. So let's open up that index.js file. What do I call that? Backend. OK, it's an empty file so far. This is going to be the top-level entry script for my backend server. The thing that this needs to do is start up a server process that's going to be listening on a port. I'm not going to be describing in detail what a port is, but the basic idea here is that I need to be listening for incoming requests. And when a request happens, I need to handle it somehow. So a pretty popular way for doing this in JavaScript is using a tool called Express. And I'll be defining an Express app in just a minute, but first I'm going to create a function called main. This is a function. I will be calling this function in just a minute. One thing I want to do is get the port that I should be listening on. And what this line is saying is that I want to, OK, you know what? Give me just a second. I just had a slight problem with my editor. OK, there we go. So what this line is saying is I'm going to ask my environment what port I should be running on. And if I don't hear anything back, I'll just default to port 5000. Again, not caring too much about what a port is. It's a networking thing. But I'm going to need to listen on that port. So I'm going to have an app. And I'm going to create that app somewhere else. But what I'm going to need to do is listen on the port that I should be listening on. And when that is done, starting up, I'm going to just print something that says I am listening on a port. In other words, like the server was started successfully. OK. So I'm going to have this make app function live somewhere else in a separate file, a file called app.js. And let's switch over to that and define the app that we want. OK, this is no, OK. I'm having some code that's finding its way into my... I was editing this code before this talk, and I forgot to clear out my editor context. So it's thinking that I meant to open the thing I had worked on before, but I'm trying to start something fresh. Sorry for the technical difficulties there. OK. New file, app.js. Here's where I need to create the main entry point for my server. And remember, this server is going to be getting requests and responding with responses. So I need to give it I need to define my endpoints to handle requests and return responses. I have this makeApp function that I needed to use in my other file, so I imported makeApp from this module and used it here, so I need to be sure to define that somewhere. And I'll be using, I think I mentioned, a framework called Express.js to do this. This is a pretty popular way to build a backend in JavaScript. Most people who build backends in JavaScript are using Express to do it, and it has different conveniences. If I didn't use Express, I'd be getting just raw data from the network whenever I was listening for a port, and I would have to do all of the HTTP parsing myself to figure out what's being requested. Is it a request that I understand and can respond to, and then handle it from there, as well as on the other side of it, generating HTTP responses by hand. Express handles those kinds of details for you, so it's a pretty convenient tool to use. To use Express, I need to require it in my module here, my file, but I also need to depend on it as a dependency of this project. So to do that, I'm going to say npm install-save express. And now this line will succeed. It will be able to require Express because we have it installed for this project. And so here I create an app. I'm actually going to say let there. And then I'm going to use something called middleware. This is getting a little bit beyond the scope of this talk. I'm not going to get into a lot of details here. Middleware is a bit more of an advanced topic. But body parser is middleware that is going to handle the JSON parsing for me. So remember, my API endpoints are going to receive, some of them are going to receive JSON bodies, and many of them are going to be, in fact all of them are going to be returning JSON bodies in the responses. And so body parser makes all of this a lot easier. This is an external library that I need to depend on. So I'm going to do the same thing here and install that dependency locally. Okay, and now onto the meat of the API. So this is my first endpoint. This is going to be, notice we've got the HTTP method here of the request, and we've got the URL path here /tweet. So this is indicating this is going to be that first API endpoint that I'm covering here. And for this one, well, the format of how Express works is that you need to give it a function that accepts a request and a response as arguments. And then the way Express works is that you use this response object to build the response that you'll actually send. And I'll be doing that, so you'll see how it works. But this is the basic format of Express. You tell it about your endpoint, and then you provide what's called a handler for that endpoint. So that's the handler function. Okay, if the request, there were some conditions here that you might remember. If the request is not JSON, then we want to return a 400 status. And this is the way to build a response here. We're saying we want to build a response of status 400, and we're not going to be doing anything else with this response, so close it out and send it back. The other thing is, and I'll get to this in a minute, is if what I'm given isn't a valid tweet, then I'll want to also return 400 in that case. And I'll define this code in just a minute. On the other hand, if everything is okay with this and we're getting a tweet body that we understand and recognize, then we're going to, sorry, I said stat, it should be status. We're going to return status 200, which stands for OK. And the JSON body of the response that we're going to return is some other function that we haven't defined yet. All right, so this is the basic framework of what this particular endpoint implementation is going to look like. We're going to add a couple things to this, such as filling in these functions to make them work, and then we're going to test it out and see if it works. Before we can really test it out, what we need to do is talk about a database. So I mentioned before we have databases. I'm actually going to close this door, getting kind of loud. I don't know if it was distracting y'all, but it was distracting me. So we have a database, and that database is going to store all of the information that we need to store. For now, we're just going to do a simple database that lives in memory. I did talk about databases should be a durable source of storage. We're not going to make it durable yet. We're just going to start and get something built to try out, and then we'll make it durable later. So I'm going to send a database handle, you might say, to this tweets.insert function that I haven't defined yet. And that's going to need to come from somewhere, and we're actually going to make that come from the makeApp function that we're exporting. So we need to pass that in, and it needs to come from yet somewhere else. So we're going to say, actually we're going to say let db is get database, maybe get database. Yeah, that should be fine. And that's going to live in a separate module called database.js. So we've got three things we need to go define: get database, and then our two tweet functions. Yeah?
What is the database now?
Right now, we don't know yet. It's just some way of accessing data. But we're going to implement that as a simple example to get started with, and then later we're going to be using a real database for this.
So, for example, I don't know, for example, Google is a database, or?
Database is just a way of storing data, like you might use MySQL or PostgreSQL or MongoDB. But it's a way of storing data, and it needs to have its own server process listening for incoming connections, and it has its own protocols that it uses. But it's a way to store and retrieve data.
Are they free, or?
Most of them are free. Yep. Mm-hmm.
Thank you.
So I'm going to create a new file, database.js. And this again. Okay. For now, this is going to be a really simple function. We're just going to return an object that contains tweets and likes as an array. And this is totally just for illustration purposes. If you were doing a real database this way, you would have problems for reasons that I'll talk about in a minute, but basically because this is not persistent, it's not durable. But it is a way for us to get started here. So we'll do that. So we got our database. Now we need a couple more methods here, such as isValid and insert as part of our tweets module. So let me switch to a new module, new file called tweet. And the two things I need to define are is valid and insert. IsValid is going to take something and return either true or false. Insert is going to take a tweet, presumably a valid one, and do something with it. It's going to store it in the database somehow. Oh, and actually insert takes a database as well. Yeah?
The thing is the keyword, or is it just...
So this is a function. This is a function, and thing is the parameter of the function. So that means something that gets passed in. And thing is just the name that I'm assigning the thing that I'm getting.
So you don't have to define it before passing it, right?
No, you do not.
JavaScript, you don't have to define.
In any programming language, you specify what name this is, because this is a function that you're defining. Another way of writing this, by the way, in JavaScript would be that's the same thing. IsValid is the name of the function. Thing is the name of the parameter that you give it. So a thing is going to be a valid tweet if several properties are true. First of all, if the type of the thing is object, and if the thing is not equal to null, and if the thing has its own property of handle, and it has its own property body, and thing.body, let's see, what did I say? Type of thing.body is string, and type of thing.handle, whoops, I typoed that. Both of those need to be strings, and in the case of a tweet, we're going to say thing.body.length is less than or equal to 280. And this is Twitter's famous constraint on how big the tweets can be. Okay, so that's a function to just check if the thing that I'm given is a valid tweet or not. This is going to control whether we return a 400 response, meaning bad request, or if we return a 200 OK, or I guess, no, it was a 201 created response. Insert. Remember that our database that we're given is just an object with a tweets property and a likes property. The way we'll implement this insert method or function is we'll do a couple of things. We need to give our tweet an ID, and we'll also give it a timestamp. And we haven't written those functions yet, but we will. And then in the tweets part of the database, this is a function I'll define in a minute, we want to add the new tweet to the end of that array. And then finally, we'll return the new tweet. All right, so tweets is going to be a function given a database. It's just going to return database.tweets. Now, this is kind of a silly thing to do at this point. What I should have maybe just said is db.tweets here, and that would have been the same thing. But I'm doing it this way because it's going to make things a little bit easier later. Also, we want add timestamp first. Given a tweet, we want to add a timestamp to it. And so we can do that this way. This object.assign is a way of transforming the given object that we were given without changing it. So add timestamp is not going to change what we're given. It's not going to modify tweet, but it is going to return a new tweet with a timestamp property. We're going to do a similar technique for add ID, except this time it's going to be next ID plus plus, where next ID starts at 1. So this is going to give add the ID of 1 for the first tweet, 2 for the second tweet, 3, and so on. OK, and now we have everything that we need. The only other thing we need to do is to import tweets. OK. Now at this point, we have one endpoint implemented. I usually don't like to even wait this long to test the code that I'm writing. In this case, I couldn't really break it down any farther. But what I'll do, I have something that I can test right now to see if everything works. This is a general thing that I recommend if you're programming, to try to test what you write as quickly as possible after you write it, while you still have the context in your head. So let's go ahead and test this. One other thing that I will add here is that I'm going to add a start script, which is going to say it's going to just run my index.js file. OK, I don't know why that came up. OK. And so now I should be able to say npm start and have a server process start, but I can't. Cannot read property, listen of undefined. Oh, I had a problem. So this is good. This is why we test things right after we write them, because we discover problems. I forgot to return app here. So let's try that. OK, great. Now we're listening on port 5000. And now we can test it to see if it works. So to do that, there's a number of different tools that you can use. I could open up a web browser and make a request. That would be a little bit tricky to get all the details right. There are tools on the command line that you can run, like curl is probably the most popular one, which actually the authors might pronounce that CURL, as in I want to see what's at a URL. I'm not sure. There's also a newer one called HTTPy, which is spelled HTTP, but it's a useful little command line tool. I'm going to use one that's a little bit more visual. It's probably a little bit easier to understand what's going on because it is visual. It's called Postman. So that's a pretty nice free tool that you can use to test APIs. I actually haven't used it until today. I had heard various friends talk about using it, but I always just test stuff on the command line. But here we go. So I've already established some different types of requests that I want to send. And I'm in my development environment, which means API host is going to be localhost 5000, which is what I want. And so I'm going to be posting to localhost 5000/tweet this body here. And this is JSON. It's just JavaScript object. JavaScript object notation is just a way of sending data. So just like I'm supposed to, I'm specifying a body and a handle to my tweet. This is the body of my tweet. It is of content type application JSON. So let's send that and see what we get back. And we got a 200 OK response. And this is awesome. This is exactly what I was hoping would happen. So it looks like we don't have any problems so far. Now, I guess what I could do is just change this a little bit and see if the sad path is correct. And it is. Happy path, sad path. Sad path is 400 bad requests, so it looks like that is correct. So let's go back and be happy. Notice now my ID is 2. Notice also, as we will see later, if I quit this server and start a new one, then my ID is 1 again, and I lost anything that was saved before. This is exactly why you would not want to implement a database this way, because the database it's not durable. It's just storing data in memory. So it goes away whenever the server's restarted. All right, so that was one API endpoint. Let's write the others. Let's actually go back to here. So we finished with this first tweet, posting a tweet. Now let's get the tweets for a given handle. Okay. So the way to do that with Express is that Express is smart enough that it understands when I say colon something here, that I don't want the literal colon and those literal characters. What I really want to do is capture whatever happens to be in this spot. And so Express is going to do that for me. And if I said /t/Jeff or /t/Nathan or whatever, then handle would get set to whatever that was actually requested. Okay, so if we get one of these requests, I'm going to save the handle out of it. I'm going to find tweets that have that handle in the database. And then if, well, let's see here. I have some code here that isn't quite like what I defined on the slide, so I'm just going to return a response. Status is always 200. JSON is tweets for user. And go ahead and close out the response. Okay, so that is the code that I want to write, but I haven't written this find by handle function yet, so let me write that real quick. And for this one, remember our database is just an array, like it contains a tweets array. So I'm just going to take DB, let's see, tweets for DB, and I'm going to filter based on whether the tweet.handle equals the handle that I'm given. Let me just make sure that I did that right. Yeah, that looks good. Okay. So let's see if I got that right. Let's go back and restart my server to get the newest code. Let's go to Postman and get tweets for user Jeff. Notice that Jeff is the handle that I posted last time. So I'm going to try to get tweets for user Jeff. And I got a server error. Okay. Tweets.findByHandle is not a function. So I did something wrong here. I need to say exports.findByHandle. That makes sense. Restart my server, come back to Postman, send again, and this time it was okay. Now there were 0 because in this run of the server, I haven't created any yet. If I create one and then come back, I see that one that I created. All right, so we got two endpoints down, 2 to go. Now let's do the like. So we want to handle the like. Okay. This is going to take, it's going to be a put method. The path is going to be /like, and it's going to take a couple of parameters. Put like and in this case, we need to get the tweet ID out. Request.body.tweet ID. And we need to test to see if we have that tweet anywhere. And if we don't, we're going to return 404 not found. If we do, then we'll actually insert the like in the database. So if Before I do that, let's actually get the body. If request is not JSON, or if it's not a valid like, then we want to return 400. Otherwise, if I can't find the tweet I'm looking for, find by ID, in that case, we will return 404. Otherwise, we're on the happy path, and we'll return a 200 or maybe a 201 status, meaning created, with the same body that we were given. But we also need to insert the like into the database. Okay, so I think that's the code that we need, but we have a couple of functions that we want to create first, isValid and insert. This is going to be a lot like tweet, but a little bit different. So I'll copy that code to start with. Thing is still an object. It's not equal to null. Has own property handle and tweet ID, both of which are strings, and we don't need that last one. Likes is going to be like so. We don't need these helper functions. And we need find by ID and insert a like, not a tweet. Okay. So given a tweet, we need to test whether the tweet's ID is equal to the ID that we were given. And we're going to say likes here, not tweets. Something like that. Let me see if I'm forgetting anything. Okay, we can actually simplify that a little bit and just do it that way. Okay, and that's just about everything that we need. So we need to import likes and let's test that out, see if it works. We want to put a like here. First, let's create a tweet. We're given the ID 1. Now there's a slight problem here, which is that, what am I looking at? There we go. The tweet ID needs to be 1 here, and this is just something I haven't actually fixed. What I should have gotten here is a string 1. So imagine that we're a string 1, and I think this should work. All right, we'll test this, and we got 400 bad request. So something about, let's see here. Something about this is valid isn't correct. We have handle, we have tweet ID. Oh, there we go. that was the problem. Let's try this again. We need to create a tweet first. Then we can try to like it. And we got a server error. Tweets.findById is not a function. All right, it should not be tweets.findById. It should be likes.findById. That's another function that we haven't created yet. No, we did do. We created that already. OK. Try this again. Post, like it, and it worked. 201 created, and we got that back. All right, 3 out of 4 down. While I'm at it, I will fix that other problem with add-id. We want that to be a string. OK, so that's done. All right, finally, we want to get the details of a tweet. This is just a simple GET request, has no parameters. So let's do that, and then we'll be done with the method, the endpoints. We'll be done implementing the endpoints. Get tweet ID. Get the ID out of the parameters of the request. And if we were not able to find the tweet, we will return a 404 response. Otherwise, we'll return a 200 response with the tweet. Actually, that's not quite right. We want to find any likes that that tweet might have as well. So we'll say likes is find by tweet ID, which I don't think we've implemented this function yet. And that's our body. So let's implement the find by tweet ID function. Likes. Hang on just a minute. Yeah, this find by ID function was not something I actually needed. This really should have been tweets.findById. That's right. OK. So I think that's maybe the right code. Let's find out. Again, being able to test this code right after I write it makes it a lot easier to be developing. So if I like the tweet, oh, I got a server error. Tweets.findById is not a function. Maybe it's because I haven't implemented that function yet. OK. There we go. Get tweet details. Let's get details for tweet 1. That's not right at all. Get tweet by ID should actually be that. Should get the 0 thing out of it. But that's not the only problem we had. Okay, let's try to do this more carefully. We're going to post a tweet. If we get all of the tweets for user Jeff, we do see that tweet. If we try to get all the details for tweet number 1, 404 not found. All right, which means that tweets.findById was returning nothing. Oh, I know what the problem is. I'm trying to get parameter ID, but I haven't defined a parameter ID. I had defined a parameter tweet ID. So I think that was the problem. Oh no, I lost my... I think I accidentally closed the other request I had. I don't know how to get that back. Oh, there it is. Okay, post a tweet. We see that tweet there. If we get details for that tweet, there we go. We see the tweet, but there aren't any likes for it yet. So let's add a like for it. Go back and get tweet details, and there we see that like. Okay, everything works. Okay. Now we've finished our API. So that's great. I want to briefly talk about what the front-end code for accessing that API from JavaScript would look like. So let me do that next. Okay, I'm going to be using a new dependency that I'll depend on in just a minute called got. Got is available on npm just like the other things were, so I'm going to say npm install save got. What got will let me do is to get to make API requests and make HTTP requests using what's called async and await in JavaScript, and this just makes things pretty convenient. This is my API host that's actually running whenever I say npm run, or npm start, I guess, which I'll go ahead and do. And I'm again going to have a main function, but I need to say async here because I need to be able to call await within it. Basically, async and await. Async is for doing asynchronous code, which means that what you can do with async is to start some process and be doing other things while it's going, and then at some later point that process will finish and give you some result back. And that's called async or asynchronous programming. Usually in JavaScript you'll be doing it with promises. But what async and await let you do is to sort of reverse that process and say, I realize that behind the scenes this is an asynchronous process, but I actually want to wait until it finishes and don't do any code until I get it back. So it can be convenient for simple kinds of programming. such as what I'm doing here. Okay, so let's test the save tweet code. I'm going to create a request for saving this tweet. And I'll do another one. I'll actually create 2 tweets. And I'm going to create a simple function to just give me some common parameters for the requests that I'm going to be making. These are going to be post methods, JSON is true, and body is just what I passed into the function. So I'm going to have another function that you give it, there's going to be an async function, you give it a tweet, and I'm going to wait for got to finish. For got, I'm going to send my request to API host plus tweet, and then I'm going to pass it those params for that tweet. And then once that finishes, I wait around for it, and it finally finishes, then I'm going to call body on it. Okay. Then tweet 1 response is going to be tweet response body for tweet 1. Likewise for 2. And let's print these out. Console.log tweet 1 response is tweet 1 response. Tweet 2 response, and I'll print a little bit of separation between these two things. So let's actually run this script. I'm going to background this process, this server process, so that I can be executing other commands while that server continues to listen. And now I'm just going to say node source/client example. And you know what I forgot to do is actually call my main function. Okay. So this is giving me a promise back, which means I forgot to call await here. So let's do that. And there we go. So I'm getting these responses back. This is a way just to kind of illustrate how you can call your API and make HTTP requests from JavaScript. I have other examples of this that I could go into, but in the interest of time, I think I'll skip those and go on to some more interesting stuff. But yeah, you can use this code as a reference. Now, I actually have all this code online. I have it in a repo on GitLab. So if you're wanting to create a backend, whether as part of the practice at the end of this workshop or on your own afterwards, I do have my final slide includes a URL for that repo that has all this code in it. Okay, now I want to deploy this somewhere. I'm going to go back and quit my server process. And I'm going to deploy this to Heroku, which I mentioned before. Heroku is basically a place for this code to live and this code to run. You wrote all this code to do your backend API, but the code by itself doesn't do anything. It needs to be running. It needs to be listening for HTTP requests at all times. And Heroku is a service that will run your backend for you, and that way you can have something that's always available and listening for requests. Heroku has a free option, which is really pretty nice when you're trying to develop things. You could drop a lot of money on Heroku if you really had a lot of stuff going there, but to start out, it's free, And there's actually no real limitations of that. I mean, you get a pretty low-powered server. The one thing to be aware of is that Heroku is going to shut down your free servers if they haven't been used for a certain amount of time, like a half hour or an hour. That's not a huge deal because they'll spin it back up as soon as there's a request that comes in. But all that means is that that request that comes in that wakes up the server, that first request after a gap, is going to take a little bit longer. It might take 20, 30 seconds or potentially more depending on your code for it to actually get a response back. But that's a limitation that is pretty easy to live with when you don't have to pay anything. And with other things, you'd have to pay, 10, 20, 30 bucks a month. Okay, so how does Heroku work? It actually works with all different kinds of languages. There's probably 8 or 10 different languages that it supports. It does support JavaScript and Node and Express. So we're going to do that, but we need to just tell Heroku how to run our server. And the way that we do that is what's called a proc file. So I'm going to do a little one-line command here to, actually I'll say npm start. And I'm going to save that to, sorry, one second. I'm going to save that to this file called procfile, and that's just a special file that Heroku looks for to figure out how to run your code. So that was the first thing I had to do. I also had to install Heroku. There's what's called the Heroku CLI that lets you access Heroku from the command line. I already have that installed, so I don't need to install it. But what I can do is use it to start out with. I'm going to use it to create an app. UNC-Makeathon Backend Demo. And so it created that backend demo for me, which if I go to my Heroku dashboard and refresh, I'll be able to see that app there. It doesn't know anything about that app yet, but I'm about to tell it. I do need, there's a few different ways to deploy to Heroku, but for the most part, you need to be working in a Git repository in order to deploy to Heroku, which you're probably going to be doing anyway. So I'm going to just create a Git repository real quick. Add node modules to be ignored by Git, and then Git status is going to tell me I have some files here. I'm going to add all of those. Create a commit. And now that I have a Git repository, what I'm going to do is tell Heroku about my Git repository and ask Heroku to set up my Git repository so that it knows about Heroku. So for the UNC-Makeathon Backend Demo app, it's going to add, Heroku's going to add a remote called Heroku to my repo. And if you're familiar with Git, what that means is that I can now push code, I can push commits to that remote. And that's exactly how you deploy. So it's actually really pretty simple. I'm just going to say git push Heroku master. I'm on the master branch, so I'm just pushing to Heroku master. And I'm getting output from Heroku right here. I'm saying building source, Node.js app detected, creating runtime environment, getting packages and dependencies. You can see that. Added 72 packages. And so it just built my code and deployed it to Heroku. So that's great. Now, what I should be able to do, for one thing, if I refresh in my dashboard and go in here, I'm not going to be able to see anything, but if I had a URL for /, I'd be able to see what the results of that were right here. But I can also see the activity. I can control who has access to this. I can see the output from that command that I just did to push. The build log. That's my build log. All that kind of stuff through the dashboard. And what I also want to do is test that I can access this. So I'm going to change, let me see here. I'm still pretty new with this, yeah, there we go. With this Postman app. What I want to do is add a new environment called Heroku. And for this one, I believe API host was what I had set. And sorry, I'm thinking about what I'm doing here. Open app, if I go here, that is my API host. If I said like tjeff, I get nothing back, just an empty array. But this is proving that this actually is the API. And I'm going to also prove that in Postman. So I'm going to set API host to this without the trailing slash and add that. And if I switch to my Heroku environment and now I try to post a tweet, then it works. Okay, so this looks exactly the same here, and this is actually kind of a neat property of APIs, is that you can deploy your API code to different places for different purposes. So you might have one API server that's connected to a development database, and that's just a chance for you to play around with the API and make sure everything works as expected. You might have a different API server that's public, and anybody can access it, and that's the sort of real production data. So in this case, we tested that it works on Heroku, and it does. And so we just deployed our code to Heroku. Pretty simple. Right, so I have some notes about that here as well. Now let's use a database. And I'm going to kind of fly through this a little bit just in the interest of time. But a database is, again, something that stores data durably so that it can survive restarts and crashes and things. I'm going to use MongoDB for this one because it's pretty simple. I don't have to explain nearly as much to get going with it. Other choices that you might consider using would be more of a traditional SQL database like PostgreSQL or MySQL. I also really like Datomic, but it's a little bit more advanced, so I wouldn't necessarily recommend it if you're starting out. And now one of the neat things about Heroku is that it has add-on services. So it has services for all of those databases that I just mentioned, except for Datomic. And you can provision these add-ons, some of which also have a free tier, to your app. So I'm going to do that for my Heroku app. I can go into Overview. I can say Configure Add-ons. I can search for MongoDB. And this MLab MongoDB is the one that has a free tier, so I'm going to use it. I'm going to provision the free version of that, rather than the one that costs $4,740 a month. That would be bad. And it's saying it installed MongoLab. Check out the documentation in its Dev Center article to get started, so I could go read that if I didn't know what to do, but I've been down this path already, so I'm going to do this. Something to note about Heroku apps, it's good practice for backends in general, is to never put sensitive data in your code. You always want to keep sensitive data outside of that, and that would include things like usernames and passwords and host names for databases. You want those all to be kind of secret. And so Heroku provides a way to manage those called config vars. And it'll actually set these config vars in the environment when your code runs. So you can access those values when your code runs without actually having the values in your source code. So MongoDB URI is the thing that I need to use here. And that's just going to be how I connect to the MongoDB database. So that said, a lot of my code is going to switch a bit. I don't think main needs to change any. Okay, database is going to need to change, obviously. This is the main thing that we're changing. We're not going to use this silly little toy database anymore. We're going to use something that's a little bit more real. So we're going to get that from a new package called MongoDB. We do need to install that package. npm install MongoDB. And then rather than this exports database function, what we're really going to do instead is it's going to be an async function now. This is my environment variable that I just talked about. So this is telling me how to actually, like, where to connect to for the database. And this is kind of silly, unfortunately. I was pretty surprised. There might be a better way to do this, and I couldn't find it. I'm kind of new to MongoDB. But this is hard to talk while I'm typing things like this. This is something I just had to do to get the database name out separately. The database name is present in the URL as the last thing there, but I couldn't access it separately, so I just had to do this code. And I wish I didn't. OK. But anyway, here I'm going to connect. This is an asynchronous function, so I have to wait on it to finish. And I get a client back. And I'm going to return, a client can contain multiple databases. I'm going to return the database named this thing out of the URL. All right, so that's my new getDatabase function. I guess I do need to change main, sorry, not main, index, not index.html. This one. I need to change this to await what getDatabase returns, which means I need to make this async. And that should be good. And that's it. Now, I can't really test this code right now. Yeah, because I've broken the format of the database that I'm expecting in my models. So I need to go change my all the stuff that uses a database anywhere. I need to go change it. Tweets is going to be a little bit different here. db.collection tweets. Find by ID is going to be find one. Need to make that async. I need to this is a way of telling, and this is just something I had to do for MongoDB. If I wanted to find an ID, then I have to call it, I have to convert it into an object ID. I don't really know why, but find by handle is an async function. This is going to be await tweets subdb dot find handle is handle to array. Insert is going to be let new tweet. We're going to get rid of the ID stuff because Mongo is going to handle that for us. Here we're going to say await tweets db.insert one new tweets and return new tweets. Okay, so I think that's all we needed to do to tweet. Let's do similar kind of stuff for like. That. that. Okay, and then finally we changed a bunch of the signatures for our model code to be asynchronous. So we're going to need to basically scatter that asynchrony everywhere. A little bit of leavens the lump. And similarly, when you start using async functions, everybody needs to be aware that now this is an async function rather than a synchronous one. Need to call await there. Await there. And there. And there. And there. And there. I think that's all. But if all of this works, then basically I would just push this code up to Heroku. Hopefully it all works. And then if this doesn't work, I think I'm probably not going to try to debug it, but basically I finished this code, so I'm going to push it up to Heroku. Heroku will deploy it for me, and then I'm going to use Postman to try to see if everything still works. Nope. So first of all, let's try that. Great, good. So far so good. Get tweets still works. Get tweet details. I need to change this a little bit. Okay, what is this? There. Need to give it not tweet ID 1, but the ID that was assigned by MongoDB. And that actually works. So far so good. And then finally put that same ID here. That works. And if we go back here, we should see that like, and we do. Okay, I guess I made all those changes correctly. That's great. Okay. So that's basically it for what I was going to show you. We've got about 20 minutes left, and it's your turn to write an API. Your mission, should you choose to accept it, is to build a backend that reports how many times its only endpoint has been accessed. And I'm going to say since the last restart, meaning you don't have to worry about doing a durable database like MongoDB. You can just store things in memory like I did here. So the first time you request it, it can return 1. The second time, it'll return 2. The third time, it'll return 3. And this is just a simple way to be storing some kind of data somewhere and to provide an API to access that data. So you have to define the API, create the API server, and prove that it works either with the Postman app or with curl and HTTP on the command line. I recommend pair programming, especially if you're not a programmer. You should definitely go look over somebody's shoulder who is and ask them to explain what they're doing. You can start with my code or use it as a reference point if you like. I have the URL there. And bonus goal, if you get that done quickly, is to add an endpoint to reset that counter so that you can have another endpoint that will reset it to 0. Now, when you're done or when it's time to go or whatever, remember to fill out the survey. The link is down here. There is a $100 raffle for filling out the survey. And that's feedback that the Makeathon requests on this workshop. So that's all I have. Feel free to start coding. I can wander around and ask questions that anybody might have. Or if anybody has any questions just in general about this content, feel free to ask those now.